Hello all. We'll have a discussion about qualitative analysis of organic compounds. Means in the given organic compound, what are the elements present? This we are going to identify by some tests. As we know, organic compound means I'm writing here OC. OC means you consider as organic compound. It contains carbon and hydrogen mandatorily. That's why we are calling them as hydrocarbons. Even though we'll take a test for carbon and hydrogen also. So for carbon and hydrogen, we are going to discuss some tests. What we are doing here, organic compound when treated with cupric oxide, CuO. CuO means here copper oxidation state is 2. CuO compound is taken so that the organic compound, whatever the carbon is present in the organic compound is converted to carbon dioxide, and whatever the hydrogen is present, that is converted to water. Organic compound contains carbon and hydrogen. Whatever the carbon is present here, all the carbon is converted to carbon dioxide. Whatever the hydrogen is present, all the hydrogen is converted to water. So the same test we are going to use even in identification and quantitative analysis also. So here we'll go with qualitative. That means whatever the carbon is present and hydrogen is present, they are converted into carbon dioxide and water respectively. As we know, test for carbon dioxide, that is lime water test, calcium hydroxide. When you are passing carbon dioxide, it forms calcium carbonate. Calcium carbonate is formed, it's a white precipitate. So when white precipitate is formed, you can confirm that that is calcium carbonate. But beware of this one inorganic part also I am including here. If you are passing carbon dioxide for a long time, then there is a possibility of getting calcium bicarbonate, CaHCO3 taken twice, which is soluble. This is soluble complex, so you won't see any precipitate. So little amount of carbon dioxide only is passed, not for long time. If you are sending for long time, calcium bicarbonate is found. Then test for water. This is one very interesting. Copper sulfate, if you take without water molecules, this is colorless. Anhydrous copper sulfate is colorless, but when you are adding water, it becomes copper sulfate pentahydrate dot 5H2O, which is of blue color. Due to the formation of blue color, you can say it is water, that what you have added to anhydrous colorless copper sulfate. So test for water is very simple. You are adding uh, copper sulfate to water, it is turning into blue. Copper sulfate anhydrous is colorless, which is converted into blue color copper sulfate. So these are the tests for carbon and hydrogen. Carbon, hydrogen over, carbon is converted to carbon dioxide is converted to calcium carbonate. Brief I am saying. Hydrogen is converted to water, which is treated with copper sulfate. You are getting their blue color. Recap, fast recap. Then nitrogen, sulfur and halogens. If these are present, we'll go with Lesense test. What is Lesense test? We'll discuss in detail. Lesense test means actually organic compound and sodium metal we take in a fusion tube. Consider this is the fusion tube. Into this fusion tube we take organic compound and sodium metal, and this is heated to red hot. After heating into red hot condition, if it is a bowl, in this water is there, into this distilled water bowl you are throwing this hot fusion tube which is containing organic compound and sodium. When this is kept in this one, it will break down, otherwise just hit it, it will break, and this solution is filtered. After filtration, whatever the filtrate is got, that is called Lesense extract. Lesense extract is the filtrate. So what is happening here? When you are heating up to red hot condition, organic compound, if it is containing any nitrogen or sulfur or halogens, these nitrogen, sulfur, halogens present in the organic compound will react with sodium and forms following compounds. Have a look at this. Sodium, carbon, if nitrogen is present, that is completely converted to sodium cyanide. Sodium, if sulfur is present, it will form sodium sulfide. Sodium, sulfur, carbon, nitrogen. If sulfur, nitrogen both are present, it form NaSCl. Sodium plus chlorine or bromine or iodine, I am writing here X, NaX is formed. What is the advantage of converting into these kind of compounds? All these compounds are ionic compounds, so the reactions will be very fast. So we need ionic compound, that's why we are converting into these compounds. So very simple, if nitrogen is present, that is converted to sodium cyanide. If sulfur is present, that is converted to sodium sulfide. If both nitrogen and sulfur are present, that is converted to sodium thiocyanate. If halogens are present, that is converted to sodium halide, sodium chloride, sodium bromide, sodium iodide. So these are the compounds formed in Lesense extract. If nitrogen is present, this sodium cyanide will be there, like that. These are present in the Lesense extract. Now, test for nitrogen. It's very simple. Take Lesense extract, add ferrous sulfate, FeSO4, add some concentrated sulfuric acid, see the result. Lesense extract, ferrous sulfate, concentrated sulfuric acid. After this, if you see any Prussian blue color, deep blue color, dark blue color, then you can say nitrogen is confirmed. The presence of nitrogen is identified by adding ferrous sulfate, concentrated sulfuric acid, then formation of the Prussian blue indicates nitrogen is confirmed. Actually, what's happening here? Lesense extract contains sodium cyanide. We are adding ferrous sulfate. These two will give you sodium sulfate plus ferrous cyanide. FeCN taken twice. Ferrous cyanide is first formed. Look at this reaction carefully. Now this ferrous cyanide, which is formed by the reaction of sodium cyanide and ferrous sulfate, will react with more sodium cyanide to form Na4 FeCN taken 6. Sodium ferrocyanide, it is called sodium ferrocyanide. Otherwise, if you want IUPAC name, that you are going to learn in class 12, sodium hexacyanidoferrate 2. Sodium hexacyanidoferrate 2. This is the name for the compound, Na4 FeCN taken 6. You learn this in class 12 complex compounds. After formation of this compound, some Fe plus 2 is oxidized to Fe plus 3 by concentrated sulfuric acid. Concentrated sulfuric acid job there is to convert some part of Fe plus 2 into Fe plus 3. So you are getting their ferric. This ferric part now will react with Na4 FeCN6 sodium ferrocyanide. When these two reacted, it will give you Fe4 FeCN taken 6 plus 12 Na plus. This compound Fe4 FeCN6 taken thrice, this compound is called ferric ferrocyanide, which is of Prussian blue color. Due to the formation of this compound, the complex compound color will be Prussian blue. This compound is called ferric ferrocyanide. What is the formula? Fe4 FeCN taken 6, like this, 3 are there. So if you want to write the name, it is written as iron 3. It is oxidation state, that is ferric. Iron 3 means ferric. Hexacyanido, 6 cyanides are there. Hexacyano, or you say cyanido, ferrate, and iron oxidation state in the complex is 2. So IUPAC name, this type of questions you can expect in JEE mains. Iron 3 hexacyanido ferrate 2. This is of Prussian blue color, which you are getting as a test of nitrogen. This is test of nitrogen. So nitrogen test is very simple. Nitrogen Prussian blue color. How you are getting Prussian blue color? Simple. Nitrogen is the Lesense extract is taken, added with ferrous sulfate and concentrated sulfuric acid. Prussian blue color indicates nitrogen is present. If sulfur is present, the compound formed is Na2S, which is treated with lead acetate, PbCH3COO taken twice. Lead acetate, then the reaction will be PbS. This is a black precipitate. The rest part is, that is sodium acetate, that we don't require here. It's a black precipitate. That means when you are adding lead acetate, if black precipitate is formed, sulfur is confirmed. One more test is there for this, that is sodium nitroprusside test. If Na2S is with you, Na2 FeCN taken 5 NO. This is called sodium nitroprusside. When they react, Na4 FeCN taken 5 NOS. Sodium, you can say the first compound is sodium nitroprusside, so you can call this as sodium thionitroprusside. Na2 became Na4, NO became NOS. One sulfur is extra, so you can add the name thio, and this is violet color. If violet color is formed when it is treated with sodium nitroprusside, then you can call that is a test for sulfur, and sulfur is confirmed. One interesting thing is, if both are present, the compound formed is NaCN. That means the first test, what we are doing, Prussian blue color test, instead of getting Prussian blue color with the same test, it is going to give blood red color. So in simple sense, I am writing an equation. Fe plus 3 will react with SCN minus to form a blood red color complex. FeSCN plus 2. Fe plus 3 SCN minus, when treated, Fe plus 2 compound is formed, which is of blood red color. But this is not good. So that's why if NaSCN compound is formed, better add it with more sodium so that it becomes Na2S and NaCN. And you can get individually the reactions for sulfur, reaction for nitrogen from these compounds. It is better. The Lesense extract nature will be alkaline in nature. So whenever you are doing an experiment, it must be acidified. Lesense extract nature is alkaline in nature because we are treating with sodium there, so it is alkaline in nature. These kind of points you try to notice, because which of the following statements are correct? or which of the following statements are wrong. In such kind of cases, these can be asked. Then test for halogens. This is interesting. From Lesense extract only. First, Lesense extract is added with concentrated HNO3. Why? What is the need? If your compound contains nitrogen, sodium cyanide is there. If your compound contains sulfur, sodium sulfide is there, and we are going to add here AgNO3 as reagent. These compounds have reaction with AgNO3. That means we are expecting a reaction for the halogens, but these also participate with AgNO3. To avoid this disturbance, we want to decompose sodium cyanide and sodium sulfide. For that purpose, we are adding there HNO3. The role of HNO3 is to decompose these compounds. Then Lesense extract, after addition of concentrated HNO3, as we were discussing, this is to decompose the NaCN and NaTS. Now we add there silver nitrate, one very important reagent. Silver nitrate is added. Then the things are very easy. If white color precipitate is formed, white PPT, which is completely soluble in ammonium hydroxide, then chlorine is confirmed. See carefully. White PPT soluble in ammonium hydroxide. Tick mark I am showing means soluble you consider. Soluble I am writing here. No confusion. Then that is chlorine. If light yellow color PPT is formed, which is slightly soluble, or you say partially soluble, or you say sparingly soluble in ammonium hydroxide, then that is called bromine. Same solvent we are taking, ammonium hydroxide only. Completely soluble is chloride, partially soluble is bromide, or you say bromine. If yellow PPT is formed, this is insoluble in, if it is not soluble in ammonium hydroxide, then this is iodine. So the white PPT formed is AgCl, the light yellow PPT formed is AgBr, the yellow PPT formed is AgI. Means AgCl is completely soluble in ammonium hydroxide, AgBr is slightly soluble in ammonium hydroxide, AgI is insoluble in ammonium hydroxide. Based on these solubilities, based on the colors of these precipitates, you can identify chlorine, bromine and iodine. One last test, we will go for phosphorus. Interesting this test. Take organic compound, use sodium peroxide. Sodium peroxide role is to convert whatever the phosphorus is present in the organic compound. That organic compound phosphorus is completely converted into Na3PO4. This Na3PO4 is converted to H3PO4 by concentrated nitric acid. So H3PO4 is the compound formed by reaction of HNO3. So first organic compound is treated with sodium peroxide, then that is treated with HNO3, so that you are getting there H3PO4. This H3PO4 is treated with ammonium molybdate. I will write the formula now. And with this, if yellow color precipitate or yellow color compound is formed, then you can say phosphorus is confirmed. What we are doing first sodium peroxide, then HNO3, then ammonium molybdate. If you are getting yellow color precipitate or yellow color solution, phosphorus is confirmed. What's actually happening here? We'll see one by one. Organic compound, if it is having phosphorus, first what we are doing, Na2O2. What is the role of Na2O2? Whatever the phosphorus is there, that phosphorus is converted to Na3PO4. This, when you are using concentrated HNO3, this is converted to H3PO4. Till now there is no problem. These are very simple equations. Phosphorus is converted to Na3PO4, sodium phosphate, which is converted into H3PO4. Now this H3PO4 is added with NH4 taken twice, MOO4, 12 moles, plus 21 mole HNO3, nitric acid 21 moles. See carefully, H3PO4 we have, that H3PO4 is treated with ammonium molybdate. This compound is called ammonium molybdate. NH4 taken twice, MOO4 is ammonium molybdate. When these are treated, what happens here? NH4 taken thrice, PO4, 12 MOO3 is the compound formed. This compound is yellow color compound. What we are saying earlier, yellow PPT or yellow compound is formed. That is this. This is yellow ammonium phosphomolybdate. Ammonium phosphomolybdate. NH4 taken thrice, PO4, 12 MOO3. Along with this, 21 moles of NH4NO3 and 12 moles of water are formed. These are the byproducts. So one very important reaction, this is a very lengthy equation is there. You must be very careful about this. H3PO4 plus ammonium molybdate, NH4 taken twice, MOO4 in presence of HNO3. It is giving you yellow color ammonium phosphomolybdate, NH4 taken thrice, PO4, 12 MOO3, right? So in this way, carbon, hydrogen, nitrogen, sulfur, chlorine, bromine, iodine and phosphorus can be tested. In 1 minute I will explain all this. You see, carbon converted to carbon dioxide, lime water test. Hydrogen converted to water, copper sulfate test. Nitrogen, sulfur, chlorine, bromine, iodine, all are taken from Lesense extract, and that Lesense extract is treated with ferrous sulfate, Fe plus 2 I am writing, from that Prussian blue color you are getting. For sulfide case, NaTs will be there after adding lead acetate and sodium nitroprusside. Both tests you can take here. For chlorine, bromine, iodine, AgCl or AgBr or AgI are the compounds formed. AgCl is soluble in ammonium hydroxide, partially soluble and insoluble. Phosphorus, it is converted to H3PO4, then I added ammonium molybdate, which gives you ammonium phosphomolybdate. Very important topic this is. You can expect one question in NEET, one question in JEE mains. Okay. Next class will be about quantitative analysis.